What is environmental chemistry? Well, environmental chemistry is the study of humans' chemical interactions with nature. Environmental chemistry should not be confused for green chemistry, which seeks to reduce pollution at its source. Let's start with one of the more well-known topics of environmental chemistry, air pollution. We won't be going too in-depth about it since other groups will have talked about it already.
Holden, why can't I breathe?
Well, Brian, you see, there's a lot of companies producing electricity, and when they do that, they actually have to put a lot of stuff into the air. A lot of pollutants, dusts, and just physical things and chemicals.
I see.
I wonder if anybody else has any of these problems.
Loki, how do you feel about the environment right now? That's good to know. I like your input. Good man.
Here's a chart of the main greenhouse gas emissions. As you can see, the biggest source of greenhouse emission is industry. That's because many require burning hydrocarbons to produce energy. Hydrocarbons are just chains of carbon and hydrogen. These chains, however, contain a huge amount of energy. These chains also usually come in the form of crude oil. So what happens when you burn hydrocarbons? To understand this, recall that a combustion reaction produces carbon dioxide, water, and energy. Hydrocarbons are perfect for this kind of reaction because they have a lot of carbon and hydrogen. All we need now is oxygen, which will come from the atmosphere. Back to the original point, burning hydrocarbon produces lots of water and carbon dioxide, both of which are greenhouse gases. Okay, so that's greenhouse gases. Another aspect of air pollution is acid rain. Referring back to the graph, the two biggest sources of greenhouse gases are also the biggest causes of acid rain. Firstly, industry produces a lot of sulfur dioxide because plants absorb sulfur from the soil. After it dies, and millions of years elapse, the sulfur remains bonded to the carbon. When we start burning this dead plant for fuel, the sulfur is released into the atmosphere where it dissolves into rainwater. And then turns into sulfuric acid. Nitric oxide gets into the air because the higher energy environment of a car engine allows a bit of O2 and N2 to react. When this is released into the air, it dissolves into water and again forms an acid. Brandon, are you aware of what you're doing to the environment right now?
Nope.
Do you even care?
No.
Well, you know, when you drive like this, you're releasing a lot of bad things into the air. And guess what? You're one of the idiots that live on the planet, so,
What?
6.5 hours later.
Holden, I think we saved the environment.
It's a good try.
Now that we have a basic understanding of air pollution, we can talk about another well-known environmental chemistry issue, water pollution. The ocean is vast. No, like vast. It's a big-ass ecosystem down there. We haven't even seen some of the life there, but yet, I can travel halfway around the world in less than a day. The ocean is massive and delicate, but still home for many living things, so you can understand why water pollution is such a crucial topic. Here's a chart of the main water pollutants. We'll be discussing industrial wastewater, offshore oil, sewage, and farm runoff. First off, industrial waste. Industrial waste includes many things, but we'll be focusing on radioactive waste. Nuclear power plants produce toxic waste, and due to their radiochemical nature, they emit alpha and beta particles. When these toxic chemicals get to critical places like groundwater or into the air near a population, these chemicals can get inside your body. When that happens, these substances will emit alpha and beta particles into your body, which is harmful to DNA. In the olden days, they literally just tossed barrels of the stuff wherever. Things have gotten better, but still, we make mistakes. An obvious example of this is the recent Fukushima accident, which has greatly affected wildlife in the ocean. This is because the radioactive chemicals are being absorbed into organisms, which then get their DNA mutated because of the alpha and beta particles.
Okay, next up is sewage. Ah, sewage. That reminds me of that scene in Les Mis. You know, yeah, what a crappy situation. Although sewage water contains many things, it is actually very high in chemicals necessary for life. By the way, what are the chemicals necessary for life? I know exactly what you're thinking. Chenops. I'm joking. It's a mnemonic. It stands for carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. These elements spell disaster for ocean habitats because they spur algae growth. This is an issue mostly because an abundance of algae will use up all of the oxygen in the water. This essentially drowns the fish because they're deprived of oxygen. Drowning fish, weird. Okay, next up, let's talk about agricultural runoff. If farms are located in a place where the runoff can get into the ocean, the effects could be problematic. Farmers often add things like pesticides into their soils. These chemicals can get carried along in water into the ocean. Pesticides are harmful to life. Seriously, you go drink some. I promise you won't like it. Anyway, these pesticides often get absorbed by organisms like shellfish and other sea creatures that is often consumed by humans. In addition, agricultural runoff also pushes algae growth because farmers often add the chenops chemicals into their soils. To finish up water pollution, we will talk about offshore oil. Despite the problems that oil already exhibits, transporting it is dangerous. If oil is spilled into the ocean, it would be potentially catastrophic. Oil is hydrophobic, and ocean animals need water to survive, so, yeah. Oil is also very difficult to clean up, so you can't just go and clean it up, you know, later.
Let's go for a swim! Yeah!
12 seconds later.
Your name is Keith Lopez, and you are dying of radioactive waste thanks to pollution. There's sewage and toxins and even some waste. Through treatment and cleaning, we can solve it now. So now the pool is clean and we can go to swim. Too bad that Keith is dead. Welcome to chemistry!
Why do people still continue to destroy the environment when it seems so obvious to not to? Let's ask our head economist.
Oh, we need to find somebody. Oh, hello, this is our head economist, Raymond Lau.
I'm going to McDonald's.
Okay.
He's out right now. Anyway, people in general love money, and things like oil and fossil fuels are the cheapest sources of energy. People don't damage nature because it makes sense, they do it because of personal gain. Okay, now here's some stuff you probably haven't heard yet. Medicines are generally thought of as good, right? They are, but they also damage the environment. You consume medicine so naturally it has to come back out, right? This affects nature because the complicated chemicals we take aren't normal in nature.
I wonder if super trees exist.
Elaborate.
You see, I think if you put medicine into nature and stuff, it'll make it stronger.
What a fine looking tree. Wow, oh my god, it's a tree!
Another kind of chemical that damages our environment is salt. That's right, plain old salt. People use salt to melt snow, but they usually aren't aware that saturated water can run off into plant life and damage it.
Are we boned?
Well, not necessarily. Nature's a very, very resilient thing. Just like at Chernobyl, nature's already taking over again. But even so, humans still shouldn't make nature's job harder.
Hold it, I think we saved the... Okay, we're done. One more time. Hold it, I think...
Fuck, okay, we're going with the first one. I don't give a shit.
More time.
Okay, pause. Okay, now go.
Holden, I think we saved the environment.
It's a good try, Ren. You did good. What the hell? This is such a simple scene!
Yeah, but... Holden, I think we saved the environment. Fuck. Getting hard. Holden, I think we saved the environment. Fuck.
What a fine looking tree. No! No, you go behind the tree.
Why?
Because you're the tree.
Oh. Oh, I forget. I have to keep pressing.